Okay, let's expand for the first three terms. So we have 1 to the power 16 plus 16, 1 to the power 15 kx plus 16, 2, 1 to the power 14 kx squared. Oh, that is 1. Then we have 16 kx and then 120 k squared x squared. And these are equal to 1 minus 4x and px squared. So 16kx equals negative 4x, 16k equals negative 4, k is going to be negative 1/4. 120k squared x squared equals px squared. 120k squared equals p. K is minus 1/4, but k squared would be positive 1/16. Therefore p is 15 over 2 or 7.5. Okay, so we've got the first three terms of the expansion and we need to look at this. Now when I look at it, I can see that there is an x on the bottom. So when that multiplies in here, it means I actually need up to an x cubed. So I'm going to get the next term in the sequence. And that's going to give me minus 35 over 4x cubed. Remember, you're doing 16, 3, it'll be 1, doesn't really matter, we can get rid of the 1. And obviously we've got the x over 4, which is negative cubed. When I sort that out, I get my 35 over 4. So now let's think of the expansion. So I want the x squared, so I want 2 times whatever gives me x squared. So if you look up here, here's my x squared term, 2 multiplied by this. So I've got 2 multiplied by that 15 over 2x squared. Then I want the 16 over x multiplied by an x cubed, as that will give me my x squared. So the next term that I'm looking for is 16 over x multiplied by my x cubed term from that sequence. And we'll simplify these so we will be adding them together. So I've got 15x squared, and I can see the 4 will go with that one of these x's will go with that one, and that gives me a minus 140x squared, as I'm just left with 4 times negative 35x squared. So that leaves me with minus 125x squared, and that is the x squared term for that expansion. So here for part A we have u1 equals 6. That means u2 is going to be 6k plus 3, and u3 will be k times 6k plus 3 plus 3, which we can see is 6k squared plus 3k plus 3. Now part B is looking at the sum of the first three terms, as it's between n equals 1 and 3. So we're looking at the sum of the first three terms. So that is 6 plus 6k plus 3 plus, if I put these in brackets you can see 6k squared plus 3k plus 3. And those are going to total 117. So now it's just about simplifying. We got 6k squared plus 9k. Then we got 6, 3 and 3. So it's plus 12 minus that 117, and that equals 0. Or we have 6k squared plus 9k minus 105 equals 0. Now 3 goes into each of these three numbers, so let's divide by 3. 2k squared plus 3k minus 35 equals 0. There we are. So 2k squared plus 3k minus 35, if I factorize that, 2k squared, 10 minus 7 is the 3, and minus 35. So now I can say that k equals 7 over 2 or negative 5. Question up here says that k is positive, so therefore k equals 7 over 2 is my final answer. Okay, so part A, now we need to look at the trapezium rule. So let's look at h is b minus a over n. So we've got it between 14 and 2, and we want 4 strips. So 12 over 4 is 3. So value of h here is 3. So let's put up a quick table. And there we have my table. Now I need to substitute those values of x in to find the values of y. So I'm going to do that now. Just remember, you're using your calculator, log 10 or log to the base 10 of 2, log to the base 10 of 5, and so on. Now in the question you can see it's the 2 decimal places, so I've gone to 3 decimal places here in my table. Now the formula is going to be, well, if we're integrating between a and b of y, we know that that's approximately equal to h over 2, and then I want to think about some brackets, and we want our y0 plus 2 lots of y1 plus y2 plus y3, and then we want our y4 outside there. Now some people put this one at the front with the y0. That's perfectly fine. It makes no real difference here. So just remembering that this is my y0, and then y1, 2, 3 and 4. Now it's about substituting all my values in. And then when I round that to 2 decimal places, I do get my 10.10. It was actually 0.995 on this one, which is the 10.10, just so you know. Now, part B, very straightforward here. Explain how the trapezium rule could be used to obtain a more accurate estimate for the area. It's simply to use more strips. So something along those lines. So see part 1 now, we're looking at integrating log of root x to the base 10. Now we need to be using our answer to part A. So what we need to do is manipulate our logs. So if I think about this, x, or the square root of x, can be written as x to the power half. And that in turn can be written as a half log x to the base 10. And remember that if I have a constant, I can take that outside. So half times 214 log of x to the base 10. Now we already worked out what log of x to the base 10 is, and that's 10.10, so we actually end up with a half times 10.10, which is 5.05. And that's my part 1 done, and part 2 is going to be something fairly similar. So let's think of it. This time what I'm going to do is just going to write this out. 2, 14, and log of 100x cubed to the base 10. Now what I'm going to do this time is I'm just going to deal with that log separately, so I don't really want to write the integral out every time. So let's have a little look. So log 10 of 100x cubed, this is log 10 of 100 plus log of x cubed to the base 10. Now, if I think of this, this is 10 squared. And then bringing my powers down, I get 2 log to the base 10 of 10 and 3 log of x to the base 10. Now, anything with the same base and the same number here is just going to be 1. So we get 2 plus 3 log 10x. Now I'm going to substitute that back into my original. So if you think of my original now, this will give me between 2 and 14. It's going to be 2 plus 3 log 10x dx. Now, when I substitute in, or if I split them up actually first, sorry, just forget my dx in there. This now means that I have 2x between 14 and 2 plus 3 lots of 10.10. So we've got 2 lots of 14 is 28 minus 2 lots of 2, which is 4, plus 30.30. And then it's just a matter of simplifying this to get 54.30 to 2 decimal places. Just sticking with how it was written in the question. Now, don't forget, if you have a calculator with this function, so it's usually, in terms of the Casio brands, it's the 991 or the 570 FX, you know, if you look at the top, you have the integral sign. If you put the original question in, for example, into the integral, you should see that it'll be roughly the same answer. So in my calculator, when I just substitute the original function here, I get 54.69659 and so on. So it's 54.7, so it's very, very close, okay, to my estimate. So I know that, you know, I'm unlikely to have made a mistake in this, and that's what you want to do. Just use your calculator to double check that your estimate is close to the actual answer. Okay, part A, very straightforward, since if I divide it by 2x minus 3, this will divide exactly by 2x minus 3. I'll be left with this negative 21, and that is what my remainder would be. Now, part B is using the factor theorem to show that x minus 3 is a factor of f of x. That means I need to substitute positive 3 in. So we get 3 squared minus 2 in the first bracket. We'll get 2 lots of 3 minus 3 in my second bracket, then minus 21. So if you look at my first bracket, I get 9 minus 2 is 7. That's then multiplied by, and we got 6 minus 3 is 3, and then we take it away 21. And 21, take away 21 is 0. Now, part C starts off with hence. So when you see hence, it usually means your previous part of the question will help you solve this part of the question. That means we want to be dividing by x minus 3. So before I do this, I want to expand my brackets. So I want to sort out my f of x. Now I'll do that quickly. And I'm left with 2x cubed minus 3x squared minus 4x minus 15. So, using long division, I'm going to look at dividing this 2x cubed by x. So that would give me 2x squared. And then what I do is I take my 2x squared, multiply by x, and then multiply it by negative 3. So that's going to give me 2x cubed minus 6x squared. And then what I normally would do here is you're basically taking away this, take away this, this, take away this. I actually like to change the signs and add them, but it's up to you. So we get 3x squared. And then let's bring down the minus 4x. Now again, we're taking the 3x squared and we're dividing it by x, and that will give me 3x. And then 3x multiplied by x, 3x multiplied by negative 3. That gives me 3x squared minus 9x. And remember, you're taking away here, so what I do is I just change the sign and I add, just because I find it quicker and easier. So this then gives me 5x, and I bring down the negative 15. Again, now take my 5x, divide by x, that gives me 5, and it's 5 times x and 5 times minus 3. So 5 times x is 5x, 5 times negative 3 is negative 15. We can see they're the same, but again, just to finish it off, I'm going to change my signs and add, and you can see here I end up with 0 remainder. This means that my f of x is equal to x minus 3 multiplied by 2x squared plus 3x plus 5. It wants me to fully factorize, so x minus 3 means I'm probably going to have I've got to have a 2x in here and an x. It needs to be a 1 and a 5. So 5 here and 1 there. And actually scratch that, because this isn't going to factorize. So just going to rub that out, and we can leave it as it is there. Started trying to factorize it, noticed that it didn't factorize, and then when I looked at part 2 of the question, it says show that it only has one real root. So then it starts to make sense, but to show for definite that it only has one real root, this will be the real root. We've got to show that this has no roots. So to do that, you need to be using the discriminant. So we need to be using b squared minus 4ac. And we want to show that this is going to be less than 0. So if I think about my a is 2, b is 3, and c is 5. So this is going to be 3 squared minus 4 times 2 times 5. So it's 9 minus, we got 8 times 5, so 40, which is minus 31. Okay, so that's what we want to show. We want to show that this is less than 0. So if no roots b squared minus 4ac will be less than 0. So this kind of thing, probably I would have put it up here first. Just now I'm thinking about it, I would have squeezed at the top there. That's what I'm looking for, and then I would have shown it. Hopefully that makes sense, guys. Let me know in the comments though if you do want me to go into more detail with this question. Now, just looking back at part 2 where we were looking at factorising, long division wasn't the only way to do that. I'm just going to show you using the factor theorem how you could have also got your answer out. So first I set it up. Here's my f of x, and then its equivalent is going to be x minus 3, as we know that that is a factor, and that has to be multiplied by a quadratic to be able to get my cubed. So this is what we're essentially looking at. Now, some people might be tempted to expand all of this, but honestly, that would be a little bit of a waste of a time. It is a little bit quicker to do it without expanding. So first things first, my x cubed. That's what I'm going to look at. So I'm going to look at the coefficients of x cubed. So on the left of my equals is just 2. That's the only number in front of my x cubed. And on the right of the equals, the only way to get x cubed is x times ax squared. That's going to give me ax cubed, so that would just be a. So I know straight away that a is 2. Now I'm going to look at the coefficients of x squared. Obviously I can't be bothered to write out the full word there. And if I look on the left side of the equals, the number in front of the x squared is negative 3. And when I look on the right side of the equals, how can I get x squared? Well, I can do x times bx. That gives me bx squared, so that will give me b. But I could have also done minus 3 times ax squared. So that's minus 3a x squared. So minus 3a. Now, we've already worked out a, haven't we? So minus 3 equals b minus 6. So b is equal to 3. And that is my second term. Now I just need to find the last. And since I can see that c is going to end up with a constant, the easiest way is with a constant. So now I'm just going to check out my constant. So looking on the left of the equals is negative 15 minus 15. And looking on the right of the equals, the only way I can get a constant, a term without an x, is minus 3 times c. So that's minus 3c. So dividing by minus 3, we can see that c is equal to 5. So now we can say that our f of x equals x minus 3, and it's 2x squared plus 3x plus 5. So this is an alternate way to being able to find essentially that quadratic rather than doing long division. And then from here, you know, part 2 for c is the same as before. So question 5, we can see straight away it's an arithmetic sequence. So a is 480, d, the difference here is minus 15. And then we want to find out the mass of silver extracted in year 14. So thinking of my 14th, remember that this formula comes from, if I do the standard one, un equals a plus n minus 1 d. So a is 480. We want 13 then lots of minus 15. And we get 285. Now, part B is talking about a total, so this is going to be a sum. And we don't know what year number it is. So remember the formula is Sn, n over 2, 2a plus n minus 1 d. So we want S of capital N, which is capital N over 2, 2 lots of, remember this is now 480, plus n minus 1, and the difference was negative 15. So, and that is going to be equal to 7770 tons. So I'm going to multiply by 2, and then I'm going to sort out what's on the inside. So we got 960 minus 15, the capital N, plus 15. Now, just sorting out the inside, and then I'll also, let's do it separate actually. So 960 plus 15 is 975 minus my 15n, and that equals 15,540. So we got 975n minus 15n squared, and that equals 15,540. Now let's get everything to the one side. So 15n squared minus 975n plus 15,540. And looking at this, we should be able to divide by 15. Just double checking. And we do in fact get exactly what we wanted and were expecting. Now, solving this, you can try and factorize, use the formula, use your calculator. It's only worth 1 mark, so you can jump straight in with it. So we've got n equals 37 or n equals 28. And so the answer will be 28, or year 28, however you want to say it. Because obviously if you stop at that value, you're not going to carry on going back to the next time that potential value can occur. Okay, so to find the centre of the circle, what I need to do is complete the square for the x and for the y. So this is going to give me x plus 5 squared minus 25, as I need to subtract 5 squared, plus y minus 6 squared minus 36 equals k. So x plus 5 squared plus y minus 6 squared equals 61 plus k. Now, the centre of this is going to be minus 5, 6. Remembering that equation of a circle is x minus a squared plus y minus b squared equals r squared. Now, for possible values of k, we can say that k has got to be greater than negative 61. Because if I think about it, if it equaled 61, or negative 61 I should say, then this would be 0. If the radius was 0, we wouldn't have a circle. Anything less than 0 is clearly not a circle. So we need this side, the radius, to be greater than 0, which means that k needs to be greater than negative 61. So, looking at this one, we know that QR is the diameter. So we want to start by finding the distance that QR is. And distance is going to be the square root of, and it's the difference in x's squared plus the distance in y's squared, and then they are square rooted. It's essentially just Pythagoras. So if I look at the difference in my x's, I've got 8 minus 2 squared plus minus 14 minus 10 squared, and then I'm going to take the square root of that. So 8 plus 2 is 10, 10 squared is 100, and minus 14 minus 10 is minus 24, and that squared is 576. So I've got the square root of 676, and that is exactly 26. So that means that I have a radius of 13. So my circle has a radius 13. That's a great start. Now, to find the centre of the circle, I want to know the coordinates at the centre of QR. So I'm finding the midpoint of QR. So midpoint of QR. And to do that, I need to add the x's and divide by 2. So minus 2 plus 8 over 2. And add my y's. 10 minus 14 over 2. And what that'll give me is 6 over 2, which is 3. And 10 take away 14 is negative 4 over 2, so negative 2. So my coordinates of the centre, which is the midpoint of QR, is 3 minus 2. Now it's very easy to state what the equation of the circle is. So it's going to be x minus 3 squared plus y plus 2 squared equals 13 squared. Now we want to find the exact value of p. And looking at point P, the y is 0. So when y equals 0, we have x minus 3 squared plus 0 plus 2 squared equals 13 squared. So I've got x minus 3 squared, and that is going to equal 169 minus 4, so 165. Now what I need to do is square root both sides and add 3. So x minus 3 equals plus or minus the square root of 165. X equals 3 plus or minus the square root of 165. It wants an exact value, so I don't need to put it as a decimal, but the other piece of information we are told is that p is a positive constant, therefore x equals 3 plus square root of 165. Okay, so we're looking at a geometric sequence in this one, where a is 4 and r is 6. Remember also that we got un, or the nth term, is arn minus 1. So we have the nth term, that final term that we're looking at. A is going to be 4, r is 6, n minus 1, and we want this greater than 10 to the power 100. So here we need to be thinking about logs. So I'm going to do log to the base 10. And hopefully you can see where this is going. And on the left side, you think about your logs, you can split these up like so. Now, anything to the same as its base, any log, so log of 10 to the base 10 is just going to be 1. So that's nice and easy straight away. So we've got log 10 of 4 plus n minus 1 log of 6 greater than 100. So we now have log 10 of 4 plus n log of 6 is base 10 minus log of 6 greater than 100. Now rearranging this, so we got n log of 6 is greater than, so we got 100 plus the log of 10 minus that log of 4. And then we want to divide. So we got 100 plus all of this divided by log 10, log 6 to the base 10. So what that means is that n is greater than, this is 128.74 or 128.7. Now we want the minimum possible value, so if n was 128, it wouldn't quite reach that 10 to the power 10 to the power 100. So we want n being equal to 129. So in this kind of case, we would have rounded up no matter what the decimal was. We would have always rounded up. Let me know in the comments if you solved this part in a different way. So now we've got a different sequence. The second term of the sequence is minus 6. So u2 equals AR 2 minus 1. So u2 equals just A times R, which is kind of obvious, but just wanted to take the steps. Now, sum to infinity, which is A over 1 minus R, should be in your formula booklet. And in our case here, this equals 25. Oh, I forgot to put this one also equals minus 6. So we have AR equals negative 6, and A over 1 minus R equals 25. Now, this is solely in terms of R, so that means that we want to get rid of our A. So I'm going to rearrange my sum to infinity one. So A equals 25 1 minus R, or 25 minus 25 R. And then I'm going to substitute that in here. So you get 25 minus 25R multiplied by R equals negative 6. So 25R minus 25R squared equals negative 6. So 25R squared minus 25R minus 6 is equal to 0, which is what we were trying to show. So as required. This is only worth now 1 mark to write down the solutions. So, you know, you can use your calculator, there's no problems there. So that gives me R equals 6 over 5, or R equals minus 1/5. Now, for part C, you need to think back to the formula we used, which is the sum to infinity formula. So I'm just going to write it back up in black. So sum to infinity is A over 1 minus R. And there's an additional bit with that, which has this alongside it. This means that R must be between 1 and negative 1, which when I look at my two answers, that means it needs to be minus 1/5, as 6 over 5 is greater than 1. So that is my reasoning. So for C, when I'm stating a value of R, R equals negative 1/5, because your R needs to be between 1 and negative 1. So along these kind of lines. So we also need to now find out our first term. So from the beginning of this bit, we had that AR was equal to negative 6. So A times negative 1/5 equals negative 6. So now we can see that A is 30. And then using my sum formula, so we want the sum of the first 4 terms. And this is going to be, I write the formula over here, it's a 1 minus r to the power n over 1 minus r. Remember, you can use the reverse one with these the other way around, rn minus 1 and r minus 1. Both are perfectly usable. It's just usually slightly easier to use this way around if r is less than 1, and the other way around if r is greater than 1. So we obviously got less than 1, so we're going to use it this way around. And there is my formula, and all that's matter now is to put it into my calculator. And we get 624 over 25, or as a decimal, 24.96. Okay, so first part of this question now is about finding turning points. Turning points happen when the gradient of them are 0. So we want to differentiate this. So 4/3 x cubed, I want to multiply by the power. So multiply by 3, take 1 away from the power. Multiply by my power, take 1 away from the power, all the way down. So I end up with 4x squared minus 22x plus k. Now, we know that dy by dx is going to be equal to 0, as it's a turning point, and it also tells me that x is equal to 2. So now I've got 4 lots of 2 squared minus 22 lots of 2 plus k equals 0. So 2 squared is 4, so 16 minus 44 plus k equals 0. So k is going to be equal to 28. And that is exactly what we needed to show. So replacing k with 28, I get my y value and my dy by dx here. Now, part B wants me to determine the range of values of x for which y is increasing. Now, y is increasing when this gradient is greater than 0. So what I want to do is I want to look at using this, and I want to first find the critical values. So these are going to happen when my dy by dx is equal to 0. Now I can divide everything here by 2 just to make my life a little bit easier. Remember, the question did say solutions relying solely on calculator technology is not acceptable. So I do want to use my brain as well as not just taking shortcuts in the calculator on this one. Now, you want to factorize this. So factorizing it should be relatively easy. 2x, x, and so on. Now, before we actually get to that though, if for some reason you're under a bit of pressure in your exam and your calculator does have the ability to solve the quadratic, you can put it in and it will give you, in this case, 7 over 2, and the second answer is x equals 2. That's what it will tell you. Work your way backwards. Think about it. I'll do this bit in black just to show you. If this was x equals 7 over 2, that means that 2x must equal to 7. So 2x minus 7 equals 0, one of my brackets. This one, x minus 2 equaled 0. X minus 2, my other bracket. And you can see now, if you do it, 2x squared minus 4x minus 7x is minus 11x. Minus 7 times minus 2 is plus 14. So you actually use your calculator, work your way backwards to get the factorized part. Okay, that will pretty much always work. The only time it might not work exactly is like in this case where this might have been a fraction that's simplified. You know, if I knew that there was a 4x squared here and I had it like this, I know I'd actually, instead of 2x equals 7, it's probably 4x equals 14. Okay, so that's just one thing to be aware of, but you should be able to use this method kind of at any time with these questions. Now, think about my graph. It was a 2x squared minus 11x plus 14, and it has two critical values crossing at 2 and crossing again at 7 over 2, 3.5. So this is a rough graph for my dy by dx function. Now, as I said earlier, we want dy by dx to be greater than 0. That is going to happen in this part of the graph and this part of the graph. These are the parts of the graph where it is above 0. Very easy. Now, that means that I want all my x values to the right of 7 over 2, because everything to the right of 7 over 2 is above 0. Everything to the left of 2 is above 0. So my values of x for when this is an increasing function is x is greater than 7 over 2 and x is less than 2. And these are my set of values. Okay, notice how I put them separate inequalities. They're separate inequalities because there's two separate regions. If I was doing below 0 and I was looking at what was in between, I'd put it as a single inequality. But it's two separate regions, two separate inequalities. Okay, so let's first work out the equation of this line. And to do that, I need the y value of m. So remember that y equals 4/3 x cubed minus 11x squared plus 28x. And we know that x equals 2 at m. So y equals 4 over 3 times 2 cubed minus 11 times 2 squared plus 28 times 2. And this gives me 68 over 3. So that is the y coordinate of m, and it also gives me the equation of the line. So the line L, now this is going to be a y equals 68 over 3 because it's a horizontal line. Now all that's left is to integrate. So I'm integrating between 2 and 0, and I'm going to do a little bit of a shortcut here because I want it in between this line and this curve, and this line is on top, it's above my region, so it's between this one and this one is the lower part. What I'm going to do is this line take away this line, so it's a little bit of a shortcut. So 68 over 3 is my y value there, minus 4/3 x cubed minus 11x squared plus 28x. Now I'm just going to quickly sort out the signs. So we get minus 4/3 x cubed plus 11x squared minus 28x. And what I'll do is I'll speed the next bit up. Equals 40 over 3. So that's one way of doing it. In this particular case, it's not necessarily much faster, but in some cases, this method will be. Now, alternatively, I could have done this. So my alternative method would be, if I look at this, this will make a rectangle. Rectangle is 2 wide, 68 over 3 tall. So I can do the area of the rectangle minus the area here, the area that is underneath this curve, so this section here. which I would get from integrating y. So if I integrated y, which is my 4/3 x cubed minus 11x squared plus 28x, and I will do this one just to show you. So we know what the integration is. Equals 32. The area of the rectangle is 68/3 multiplied by 2. So that's going to be 136/3. So the area of R is going to be this 136/3 minus 32. And of course that equals 40/3, as we've already seen. So this is an alternative way. It's totally up to you which way you do it. Sometimes the previous method, where you do one line take with the other one, that works really well when you've got a diagonal line or two curves, as it saves you a lot of time. In this particular case, there's not very much difference either method. Let me know in the comments which way around you preferred it. Let's start by squaring both sides. So x plus y squared over 4 is greater than or equal to xy. So x plus y squared is greater than or equal to 4xy. Let's expand. X squared plus 2xy plus y squared is greater than or equal to 4xy. X squared minus 2xy plus y squared is greater than or equal to 0 when I subtract this here. Now this is an x minus y squared is greater than or equal to 0. So what I've done here is kind of just a bit of information, a bit of jotting, and this now is a good place for me to start my proof. So x minus y squared is greater than or equal to 0, because I always need to start the proof with a fact, a known fact. That's how I need to start the proof. So I've just put in the word consider. Now I'm essentially working backwards from my notes earlier. So from this I will expand it. X squared minus 2xy plus y squared is greater than or equal to 0. X squared plus y squared is greater than or equal to 2xy. Now if I complete this square, I get x plus y squared minus 2xy is greater than or equal to 2xy. X plus y squared is greater than or equal to 4xy. Now x and y are both positive, and this would also mean that x would have to be greater than 0 and y would also be greater than 0. So I can now do the square root. X plus y is greater than or equal to the square root of 4xy, which will be 2 root xy, and then I can divide by the 2 and I'm done. So part 2 is nice and easy. Prove by counterexample that this inequality does not hold true when x and y are both negative. So first of all, let me just write down what we are using. We want x and y to be negative, and really what I want to do is something where it has a nice square root. So I'm going to use minus 2 and minus 2, because minus 2 times minus 2 is 4, which I can get the square root of. So let's have a little look at the left hand side here. We get minus 2 over 2, so it's minus 4 over 2, which is minus 2. the right hand side we have root of minus 2 times minus 2, which is 4, which is 2. Minus 2 is greater than or equal to 2 clearly doesn't work. And that's how I would then essentially finish some sort of statement just to say, but this doesn't hold true. Something along those lines. So I would probably start off by letting theta equals this 2x plus pi by 4. Then I've got tan squared theta equals 3. And if I think about my range, which is currently between pi by 2 and negative pi by 2, 2x would be between pi and negative pi, and 2x plus pi by 4 would be between 5 pi by 4 and minus 3 pi by 4. And that is my range for theta. So theta equals what would be 60 degrees, so pi by 3 radians. So using the cost rule, we've got our first angle, and we're actually going to use all 4 quadrants. One for our positive ones, which is here and here, and one for our negative ones, which is this section and this section. So we've got pi by 3, pi by 3 in all of these acute angles. So around here we've got pi minus a third pi, so that's going to be 2 pi by 3. In this direction we're looking at negative 1, so I'll do these ones in black. Going this way we're looking at negative, all the way around to minus pi. So we're looking at minus pi by 3, and then we're looking at minus pi plus pi by 3. So for theta, I have 2 positive values, pi by 3 and 2 pi by 3, and I have 2 negative values, which is minus pi by 3 and minus 2 pi by 3. Kind of nice in this particular case. So those are my values of theta, but don't forget that theta was equal to 2x plus pi by 4. So what I need to do is I need to take pi by 4 away from each of these values, and then I need to divide it by 2. Finally, I like to just double check everything. So first check these 4 are still in the range between minus pi by 2 and pi by 2, and they are. Then I usually like to check at least one of them, but I will check all of them sometimes if I have time, into the original equation. So take the angle, double it, add the pi by 4 or the 45 degrees, and square it, and you should get 3. So, no obvious place to start, so let's start by expanding the brackets. 4 sine squared theta minus 4 sine theta cos theta plus cos squared theta equals 1. Now, I'm going to put 3 sine squared theta here minus 4 sine theta cos theta plus sine squared theta plus cos squared theta equals 1. What I've done is I've just taken one of these sine squareds, and I've just popped it over here. So I've just split the 4 sine squared up into 3 sine squared and 1 sine squared. And the reason I've done that is sine squared plus cos squared equals 1. So that means I get 3 sine squared theta minus 4 sine theta cos theta plus 1 equals 1. So the 1s will obviously just take away 1 from each side. That will give me 3 sine squared theta minus 4 sine theta cos theta equals 0. Factorize out the sine. Gives me 3 sine theta minus 4 cos theta. That means that sine theta equals 0, or 3 sine theta minus 4 cos theta equals 0. So this is 3 sine theta equals 4 cos theta. Sine theta over cos theta then would be 4 over 3, or tan theta is 4 over 3. So from that, theta would be 0 and 180 and 360 is what we initially think, but if I look here, it can't equal 0, it can't equal 360. So on this side we've just got the angle 180. Looking on the tan side, I get 53.1 degrees. Now just checking in my cast diagram, tan is positive, and it's positive in these two sections. So my second answer here is going to be 180 plus that 53.1. So in total, my angles are 53.1 degrees, 180 degrees, and 233 degrees, or 33.1 degrees. Now, I do believe there were a few different ways of doing this part of the question. If you did do a different way, please let me know in the comments.